Good evening, everyone. I am Hemanth. Today, our team gonna discuss on the paper serverless computing a security perspective, and my team members are Srinidhi, Anjani, and Oviya. So, in this video, I'm gonna cover the topics: abstract, introduction, problem statement, methodology, implementation, results, conclusion, future work. And coming to the abstract of the paper, serverless computing is a cloud architecture model which is taking over nowadays. In this model, the developers can run code without managing the servers, by which they can freely focus on the business logic, and the cloud providers will manage all other aspects, like from provisioning to scaling and to infrastructuring the security. And this also brings many benefits like lower cost and security, simplify operations. But it also has raises a questions: what happens to the security when server disappears? Uh, and in this paper, they mainly focused they mainly focused on the function as a service, which is a core element of the serverless computing. and and to understand the problems in the serverless computing, they build a structured threat model, and they also identified key attack vectors, mainly like event injection and over excessive permissions in the IMI roles, and data leakage via shared backend services. And they also analyze some isolation mechanisms, permission controls, and the transparency between the resources and cloud providers. Uh, and the paper also not only discuss about the problems, but it also offers security recommendations, and 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 says what we need to do in the future to increase the security for serverless computing. And coming to, like, let me walk through how we got to the serverless computing. First, we have used VMs, which provide a strong isolation, but also has high management overhead, like in which we need to configure, manage, and provide everything. Like we need to babysit the whole things, which is complex for the developer. And then came containers, which are faster, lighter, and more efficient. But for containers also, we need developers when we need to manage infrastructure, like when we need to use tools for orchestration, for like Kubernetes tools. And then came the serverless computing, in which developers just write the business logic code, and the cloud provider takes takes how to run, how to connect, and how to manage the servers. So, and in serverless computing, it is mainly like pure pay as you pay as you use. Like if it will, if you will get paid for how much time you use the function. So it is moved from fixed pay to pay per use. Serverless computing is mainly divided into two core parts. One is FAS and BAS. FAS is a function as a service, and BAS is a backend as a service. Function as a service Think of it as a little block of codes which is stateless, short-lived, and event-driven code, and provided, and where developers only write the business logic, and provider takes care of the rest. And BAS BAS is backend service where it provides the external dependencies like authentication, file storage, and authorization database. So it also has benefits like scalability, low cost, and it also removes the burden for the developer, like of operating the servers and managing the servers. But it also has many benefits, but it also has some security issues, like as we use more function as a service in serverless computing, there are many short block of codes, like many functions will run for them for the many times. So there are small codes. So when there is a chance, there are more chances that attacker can get into the our system and get classified information. So as function FAS is good in serverless computing, but it also has some security issues. And before, a developer use it to has permissions for the OS and the servers, but as in serverless computing, the cloud provider manages all the infrastructure. There builds new trust boundaries as developers can't see what is going behind the functions and what is happening next to the functions, and it also reduces the visibility for the developers. So next part will be continued by my teammate Oviya.
Hello everyone. Today I'll be speaking about the security challenges in serverless computing, especially from our analysis using GCP as a case study. So I'll start with the problem statement. As a cloud computing evolved, we have moved from managing virtual machines and containers to serverless architecture, where developers only write code and other cloud providers take care of everything else. While this offers scalability of ease development, it also introduces new unique security challenges. So let me outline the main issues we discovered in this case study. Um, Multiple event triggers like HTTP cloud storages widen the attack surface. There is a limited visibility into how containers are used or scheduled, which hides potential risk. Whereas IAMS configurations is where developers often assign excessive permissions, which can lead to privilege escalations. Securing microservices at scale becomes complex because serverless systems scale rapidly, communicate through various cloud services. So, in simple terms, traditional security models don't work well in this fast paced, challenging, event driven environments.
Hello everyone. Today I'll be talking about serverless security on GCP. Serverless helps companies save time, reduce cost, and scale easily. Developers will just focus on the code. GCP takes care of the rest, managing servers, scaling, and patching. But with this flexibility, there will be new security challenges. Since we don't manage the servers, we rely on GCP's protection, but we still need to secure our apps from external threats and internal misconfiguration. So in this presentation, we'll cover the key GCP serverless services, their risk, and how to improve security. So let's look at how Let's look at how different GCP services impact serverless security. First is cloud functions. It can be triggered from outside. If inputs aren't validated, they may cause code execution or leaks. API gateway is the first line of defense. If it lacks authentication, attackers can bypass it and hit backend functions directly. And next comes IAM. It decides who has the access. If roles are too broad, attackers or mistakes can cause damage. So every time we have to use the least privilege principle. And next is cloud storage. It can expose sensitive data if buckets are made public by mistake. And next is PubSub. PubSub is publish and subscribe. Like it lets the services talk, but if anyone can publish messages, a fake message could trigger dangerous actions. So each role plays an important role in security and it needs a careful setup. And next, coming to the architecture. So let's discuss on how all these components work together in a typical app. For example, a user uploads a file, it first goes to the cloud storage, and then it triggers a cloud function. The function sends a message to PubSub. An API gateway will protect the endpoints, and IAM controls what each service can access. So security is not just each part, it's about how they are connected. For example, if IAM gives too much access, a function might delete files. Like if PubSub isn't secured, someone could send fake messages. So monitoring, permission, and secure integrations are the key. And next, coming to the principles. So first we have statelessness. Functions don't keep data between runs. This reduces leaks, but every input must be rechecked. And short-lived functions run briefly, reducing attack windows. And fully managed GCP handles patches and scaling, but at app level, security is still our job. And decoupled services. If one function fails, others will still continue. This will limit the impact. So these principles are helpful, but only with good practices. And next, coming to the strengths and risks. So strengths of the serverless on GCP are short execution time limit attacks, IAM control access, infrastructure is auto patched, apps scale automatically, and risks are injection attacks if inputs aren't validated. Warm containers may retain sensitive data. Over permissioned IAM roles are a big risk, and limited visibility. Without logging, it's hard to detect issues. So these risks don't come from GCP itself, but how we configure things. And next, coming to the threats and recommendations. So threats come from two resources. First will be external and next will be internal. External is from the hackers. Hackers will send many malicious input or fake messages. And internal will be like over permission roles. For example, if we give too many permissions to a developer and by mistake uh, they give roles while configuring the app, it will cause a lot of issues. So what are the recommendations for this? We should always use least privilege IAM, monitor warm container behavior, use security command center for alerts and visibility, secure function environments with smart scheduling. These steps will reduce risk and protect our serverless apps. So to conclude, serverless on GCP is powerful and flexible, but security is still shared. It's a shared responsibility. GCP manages the platform, but will manages app settings. By understanding how services work and following best practices, we can build secure and reliable applications. Thank you, and implementation will be taken over by Srinidhi.
Hello everyone, this is Srinidhi here. I'm gonna talk about implementation now. In this slide, we examine both the strength and the weakness of GCP serverless architecture. On the strength side, the feature like built-in auto-scaling help observe traffic spikes, reducing the impact of DOS attacks. Also, short-lived containers lower the chances of attackers establishing the persistent presence. So GCP also handles patching and infrastructure. reduce developer overhead, and provide isolation mechanism via VCP connections. However, here are notable risks. IAM role can be complex to set up and may lead to privileged risk. And the serverless nature means a wide attack surface from HTTP trigger or PubSub GCS. And there is also limited visible into how containers are reused or scheduled, which can lead to security blind spot. Lastly, served service can open the door for side channel attacks. And on the other hand, I'm gonna change it to the next slide, which is so here we conducted a threat modeling exercise specific for GCP serverless application. We analyzed two main threat categories. So one is external attack like injection via API, and the internal attack such as misuse of IAM roles or insider access. Based on our findings, we recommend enforcing least privilege IAM rules with automation, monitoring warm container state more closely, and third thing is improving observability using GCP, Security Command Center, and lastly, researching better container scheduling strategies to avoid co-location risk. These suggestions aim to build a more attack-resistant and transparent serverless environment on GCP. So, serverless security enable and risk-based. Here in the slide, contrasts how serverless can act both as server security enabler and a security risk. On an enabler side, serverless architecture limits how long threat can persist, and short-lived functions reduce the attack windows. And the last but not the least, auto-scaling ensure resilience against DOS attacks. And the shared responsibility model allow developer to offload infrastructure security. However, on the risk side, a large number of triggers expand the attack surface. Shared environments frequency inner functions call increase vulnerability. And execution environment like gvisor share the host kernel and are not fully uh, weighted. And the warm containers can retain states and predictable scheduling, maybe exploit for co-location attacks. This dual nature is central to understanding the unique security posture of serverless computing. And the next slide, which is cloud component and security roles. So here we examine specific GCP components and their security implications. First thing, IAM. IAM offers a granular control, but misconfiguration can create major security gaps, often by over-provisioning permission. On the other hand, VPC connectors, it helps isolate function from the public internet, which is crucial for minimizing exposure. Though setting them up in serverless context can be challenging. On a final note, environment variables. So, environment variables are convenient, but pose a severe risk if they store sensitive data like credential, and especially if those values are not encrypted or on improper access. Each of these components requires thoughtful configuration and monitoring to ensure serverless application remain secure. The next slide. Here is the implementation observability. So I'm going to talk about these areas and its enabling and risk factor. Based on our hands-on review of GCP serverless ecosystem, we observe a mix of enabler and risk. So the function lifecycle, it's a benefit from stateless, but residual state in warm containers remain a concern. And IAM configuration, it is complex but can lead to human errors. And execution environment, which are sandbox with the gvisor but lack third-party audits. And scaling, auto scaling enable elasticity but may lead to DOS attacks where attacker inflate billings. And finally, the communication. Communication between loose coupled service is powerful for scalability but hard for security, especially across function boundaries. This slide enforces that while GCP serverless offers strong security feature, practical implementation introduce nuanced risks. So from next slide onwards, the result stage, my teammate Oviya will be taken care. So I'm signing off here. Thank you.
In result, we analyzed the serverless application in GCP came across some interesting findings. So I'll start with the positive aspects. Stateless function reduce these chance of long-lasting attacks, and auto-scaling helps defend against DOS attacks, and granular IAM role allows fine-tuned access control. Tools like Security Command Center improve visibility and monitoring. But we also found some serious limitations. So, large number of triggers still make the system vulnerable. IAMS configurations are common and dangerous. Warm containers may retain a state, opening the door of residual threats. Issues like cold start and race condition introduce unpredictable behaviors. Moving to conclusion. In conclusion, serverless computing is a powerful and cost-efficient model. It allows fast deployment and removes infrastructure headaches for developers. However, it comes with serious security concern, including expanded attacks, surface, and reduced transparency in cloud internals. So, the takeaway from this is security in serverless computing is a shared responsibility, while cloud providers handle the platform. Like developers must secure their own code, access permissions, and data. There is an urgent need for better tools, automated policy, and increased transparency from cloud vendors. Serverless is our future, but to make secure, our security strategies must evolve too. So the future work will be explained by Hemanth, and thank you.
Let's talk about the future work, like what we need to do to increase the security and transparency for the in serverless computing. And first, one main thing is like we need to dive deeper into the analysis of custom execution environments like gvisor in GCP. Like we need to understand how secure the sandboxes really are, and we also need to build automated tools to generate IAM policies, which helps developers to not give excessive permissions for the IAM roles they create. And we also need to investigate into the race conditions and long-lasting attacks in warm containers, because they are not isolated as we think. And we also need to increase defenses against side channel and Daniel wallet attacks, as the attacker can cost you money by triggering your functions. And by most importantly, we need open collaboration between the cloud provider and the researchers so that we can reduce the transparency and the security. Thank you.